Terry VanNoy, and welcome into this video about determinants. Now in this Algebra 2 topic, I've gone through the whole sequence of finding a 2x2 determinant, what that process is all about, 3x3 determinant matrix, and then using that with Cramer's rule to solve systems of 2x2 or 3x3. You've had some problem sets along the way, and now it's time to finish this final video, which is Self-Quiz 2. So we're going to focus on 2x2, 3x3, Cramer's rule, solving some systems of equations. So I have 3 examples for you. We're going to do the first 2 together. Good luck. All right, we're looking at numbers 4 and 5. We have 2 equations, 2 unknowns, and what you're going to do is, hopefully you've gone through the series and you know how to set up your matrices, and you're going to find the determinants and use Cramer's rule to solve for x and y. All right, pause the video and give both of those a try. You can see the final answer on number 4 is x is positive 3, y is negative 2. So here's the process in case you couldn't get that right. And you're going to do it in 3 steps. First, we're going to find the determinant of the coefficients themselves. That's the x and y coefficients. So that's going to be a negative 1 and a positive 4 for the x coefficients, and then a negative 2 and a negative 1. Alright, so what that's going to be, of course, is multiply the diagonal there, which will be a positive 1, and then subtract the product of the other diagonals, which is a negative 8. And that is going to give us, notice the sign change there, that should be 9. Next, we find the determinant of the x group, which is going to be 1, 14, negative 2, negative 1. Now remember that the y coefficients stay the same, but the x coefficients get substituted by these constant numbers here. All right, so that's the trick. For the dx, the x's get substituted. All right, let's go ahead and do that determinant, which is negative 1, subtract negative 28, that's going to be positive 27. All right, what is the dy matrix 2x2 that we have to take the determinant of? Well, the x coordinates, x coefficients are going to be the same, negative 1 and 4, but the constant coefficients get substituted in where the y ones are. So it's going to be a 1 and a 14. If you know where to substitute those coefficient numbers in finding these, using Cramer's rule and finding these determinants, then you're all set. It's not that hard. So let's cross multiply. That's going to be a negative 14. Subtract the other product here, which is 4, and that is going to be negative 18. So to find the x value, we're going to take the determinant of the x group, which is 27, and divide it by the determinant of the coefficients, which we knew was 9, and that would be positive 3. Determinant of the y group is going to be negative 18. Divide it by the determinant of the coefficients, which is 9. Now that'll give us a negative 2. Therefore, my answer of 3, negative 2. All right, let's try number 5 and see if you got that answer. We have negative 5, negative 5. Well, again, we're going to start with the determinant of the coefficients. So that's going to be a positive 1, negative 5. See those right there. And the y coefficients are negative 4, positive 5. All right, that's going to give us, multiply the product there for 5. Don't forget to subtract. Those, that product right there is a positive 20. So 5 take away 20, negative 15. All right, we'll use that in our last step. So let's record that. Now, d of x and d of y. Do you know what those 2x2 matrix would look like? Let's check. All right, did you write this? Here are the coefficient numbers, which come from here, and that gets substituted in the x coefficient column. For the dy, we move it over for substituting for the y coefficients, and the x coefficients stay the same. All right, I hope you got that. All right, so 15 times 5 is 75. Take away this product, which would be 0, and so of course 75 will be the answer there. Next we have 1 times 0 and negative 75, which again gives me a positive 75. All right, let's put it together and find out what x and y are. Both going to be 75 divided by negative 15, which is negative 5 in both cases. All right, so therefore, our ordered pair solution for that system of equations, negative 5, using Cramer's rule. All right, one last example in the self-quiz, and I challenge you to try it. It's a 3 by 3. Let's take a look. All right, number 6. Be careful with your coefficients there and use Cramer's rule to solve that systems of a 3 by 3. Good luck. All right, my answer is x is negative 5, y is positive 4, and z is negative 1. So remember the process of find the determinant of the coefficients. Well, the coefficients, the x coefficients, negative 4, negative 4, negative 5. All right, what I have to do is construct the coefficient determinant, which is going to be this 3 by 3. Now notice that here I have a 0 because there is no x term in that third equation. So make sure you put a placeholder 0 in there and just double check that your signs and all your numbers are correct. Now the key here is this first column of numbers. So I have a negative 4 and a negative 4. But remember that the middle number here changes its sign because we are subtracting it. So be careful about that sign change. And then of course it's 0 here, which means I'm going to add 0 times another determinant. But we know that that's going to just cancel out and give us a 0 anyway. So we'll kind of ignore that. So it's going to be those numbers from the first column there times the determinant of the rest of the numbers. So here this first negative 4, which we put here, as you remember, we ignore the row that number's in and the column that number's in, so that we're going to use these 4 numbers right here. So let's copy it down correctly. Negative 5, negative 5, negative 6, negative 19. All right, for this middle 4, which changed its sign, remember, we're going to ignore this row, this column. So it's going to be negative 1, positive 1. And negative 5, negative 19. A little tricky to get the correct numbers in the right location. Now, normally I would put the 0 here, and that gives us these 4 numbers in this determinant. But remember that that is going to be, that's going to be gone anyway. So we're going to just ignore that part, and we actually are going to have to just do the math in this part right here. So, moving on with that, we're going to get negative 4 times negative 25 plus 4 times 6. Now if you don't see where I got these determinant values here, you might want to review that one previous video about a 2 by 2 determinant. So I won't take the time in this video to show that step. I hope that's alright. Final answer there for that determinant is positive 124, and we'll use that to figure out our x, y, and z values later. Alright, let's do the determinant of the x's. Alright, I'm going to speed this up a little bit. Again, I hope that you understand finding these 2 by 2 determinants and how to figure out which determinants go with which number. So here we have 15 times that determinant minus 6 times that determinant minus 19 times that determinant, which gives us these results, and that final total there is, believe it or not, negative 620. Now it seems like a pretty huge number, but it's going to work out. So let's go on to the dy. For the determinant of the y group, I'm going to have the x coefficients and the z coefficients, but the y coefficients are substituted by those constants, as I've shown in an earlier procedure. So now we're going to take the first column of numbers, negative 4, multiply it by the determinant of the remaining numbers, minus 4, but remember we're subtracting, so it becomes a positive 4. And we're going to multiply that by a determinant of the remaining numbers. And then the 0, which is, of course, not going to matter because that is just going to disappear. So we're going to ignore that 0 group, but let's look at the first two groups. Did you place those numbers correctly in the determinants? Double check that you have the correct signs, but it should be those two right there. All right, let's keep going. The answer should be 496. I hope you did okay on that. And then the final step here, in this phase at least, is to find the determinant of the z groups. What's that look like? Notice that the z coefficients have been substituted by those constants, but the x coefficients and the y coefficients are the same. And now we're going to focus on this -4 number in the first column. And I ignored that row and that column, which gives me these 4 numbers for the determinant. So we're going to have -5, +6, -5, -19. Okay. And in this group, the 4 is negative, but remember we're subtracting. Don't forget that sign change right there. And that is in the second row, first column. So we're going to grab these two numbers, -1 and +15, and -5, -19 again. All right, let's finish our work and see what that is. The answer should be -124. So to find x, it's the determinant of the x group, -620, divided by the determinant of the coefficients, which in all three cases is a +124, and therefore we get -5. Looks like some pretty big numbers, but it turns out to be a nice simple answer there. Now y is going to be the determinant of the y group, which is 496, divided by 124, which happens to be 4, +4. And z is 124 negative over 124 positive. So of course that's going to be a -1 for my final answer. In coordinate form, I'm going to get that answer right there, as you can see. All right, it's a huge amount of writing and a little tedious, but if you can keep track of what you're doing, this is one way to solve a system of equations, in this case 3 by 3. So thanks so much for watching these videos in this series. It's a little bit tough, but I hope that you made your way through it and share with me how things are going for you. Thanks for watching.